Okay, for question 2, it is a question on vector diagram drawing. Whenever you are given this type of question, right, I strongly advise you to use the head-to-tail method. In the textbook, there is another method called parallelogram method, and if you have uh, been using it to solve questions, you will realize that you are unable to do this, because for parallelogram method, you can only deal with two forces, and when you have three forces system, the parallelogram method does not work. So how to apply your head-to-tail method here? For head-to-tail method, it is very important that you find out the angle, the force factor made with either the vertical or the horizontal. So before you start drawing your diagram and whatsoever, what you need to do is you can see that there are three force factor here, right? T, R, and W. So this is what I call force factor. In another word, how many arrows are there lah? Okay, if you don't like technical terms, force factor, okay, basically means how many arrows are there, right? So here you can see there are three. So once you identified them, right, what you need to do is you need to find out the direction. What do I mean by direction? It's not north, south, east, west, or north, east, and all that. It has to be an angle. And whenever you want to measure an angle, right, you need to measure the angle between two lines, right? So for force factor, the two lines that I'm referring to will be the arrow itself, and you need to go and create a reference. This reference has to be either the horizontal or the vertical, right? So in another word, in mathematics, this is called the bearing, if you remember your mathematics. So especially for those the mathematics, especially geometry, you are not so good one, right? My advice to you is before you even start drawing the vector diagram, go and draw the bearing for each of the forces. Of course, for forces like your force T, you can see that it is a horizontal force towards the east. So you don't really need a bearing there. Similarly, for your weight, right, it is just a vertical force. So there's nothing much to worry about. You just need to draw a straight line down. So it's okay, right? But the problem is with this force factor R. Force factor R is like a diagonal vector that points at a certain angle. So what you need to do is you focus on this and you sketch the bearing here first. Why do you need this? Because when you want to draw this force factor R, you know that it is going somewhere northwest, but exactly how north or how west you do not know, right? So either you have to measure this angle or you have to figure out this angle, the red one or the purple one, up to you. So how do I do that? You need to use a bit of geometry. So down here, can you see that if you zoom in, there is this triangle right here that give you this angle, which is 35. So if you are good with your geometry, if this is 35 and this is a 90-degree angle, because this bearing is vertical line, right? So you know that this purple shaded angle, it will be your 90 minus 35. So if you extend it, right, if you draw this line and if you draw this green color line, can see or not? So any angle between this green and purple line is the same. So I know that this is the same, the green color quadrant is the same as the purple quadrant. So this green quadrant is 90 minus 35, right? Correct or not? Then in another word, you also know that this part over here is 90 degree. So this means that this red quadrant, right, is your 90 minus 90 minus 35. In another word, if you solve this, it is equals to 35. So now you have this bearing, you know that, oh, my force factor R is making an angle of 35 degree with the vertical. Right? If you do not like the vertical, then you can also work out what is this purple quadrant. So in this case, I think by now you should be able to see that this is your 90 minus 35 lah. Okay, once you have that, things will be very straightforward. Okay, go and pick a scale that you are comfortable with. You can be 1:10, 1:2, 1:5, as long as you have enough space. Make sure in the scale you go and mention what is the unit. Okay, then after that, just start drawing. You have three factors, right? You have T, which is towards the right. You have W, which is down. And then you have R, which is towards the north west. And it is basically 35 degrees from your vertical. So what you need to do, quite straightforward. The only vector that you know exactly is this 60 kg. And from this 60 kg, you can work out that your W is just 600 Newton. So that is the easiest one to draw lah. So you just start from a point, right? Draw your bearing. Like I always say, draw your bearing. If you know that you are weak in vector drawing, right, just do it step by step. Don't skip step. Okay, this is my start, right? So here I will even tell myself this is my start. Okay, so start, I will draw downward because my weight factor is downward ma. So down here, right, this thing over here is my checklist. Okay, then I'm done here. I will go and put W. Okay, for me, I don't have a ruler on my iPad, so I will just sketch it. For you, you go and draw. Then after that, the next thing that I can draw very easily is this T that is going to the east, right, and is horizontal. Okay, but for this T, I do not know its length. I do not know its magnitude. I only know that it goes to the right. So for me, what I will do is that, okay, now it goes to the right. I'll go to the right infinitely. I don't know when to stop. So I just draw until here. Okay, if I find that now I'm stuck, I do not know how to proceed already. Okay, now then I move on to the next question. Okay, but for this, then now I go and see. Then it says what? Okay, in the question here, it says constant velocity, right? Constant velocity means what? Your acceleration is 0. Acceleration 0, it means what? It means that your F net is 0, right? If F net is 0, it means that when I want to draw the third force out, the third force will somehow return to the origin, right? So now I need to draw the third force that comes back to the origin. So what to do? Where is my third force? This is my third force, right? My last force is the force R. So it means that in my mind, I know that, oh, okay, I have sketched W down, but I don't know what is T. But I know that at somewhere over here, if I draw an arrow up, I should meet the start point, right? And I know that when I draw this, my R has to be 35 like that, correct or not? In another word, can you see that there is an alternate angle over here? Means that this is 35, right? So it means that my vector R will approach my start point at an angle of 35 degrees towards the vertical. So what I do, I will put my projector. Okay, I don't have a virtual projector, but I can draw one. I put my projector here, and I will go and measure that, oh, okay, 35 degrees, I will have a certain vector that will cut T at this point. So once I have this, I can see that, oh, there's an intersection here. What does it mean? It means that my R has to start here so that it will reach my start point, right? And it will give me 0 F net. So therefore, now once I know this, I can then complete my vector diagram and I see that, oh, this is my T, right? And as you can see in my diagram, there is no double arrow, right? Because my F net is 0. So once I do this, I will be able to measure this part over here and answer my question. So that is how you approach part A. Okay, as for part B, it taps on your knowledge about Newton's first law. So what do I mean? So now it says what? The question says that the surfer released the rope. So when you release the rope, one of the force will disappear, right? So let me erase this. So if I release the rope, what will disappear is, of course, tension, right? So if I do not have tension, what will happen to my free body diagram is that I will have something like this, right? if I lose the tension. So if I lose the tension, I have something like that. Can you see that this looks like a start point and this looks like an end point? Meaning that most likely I will have a net force that is in this direction. And what I have learned is that if my net force is in this direction, my acceleration will also be in this direction. So the question you need to ask yourself is, does acceleration indicate the direction of motion? If my acceleration is towards the left, does it mean that I will be moving to the left? The answer is no, right? Your direction of motion depends on your velocity. So very similarly, for example, if now my bus is going into a bus stop, it will be driving this way, right? But it will be slowing down, correct or not? At this point, your acceleration is this way. So this example tells you that your acceleration does not dictate the direction of motion. It is the velocity. So let's go back to the question. Here the question, right? When the server released the rope, the server is actually going in this direction. So what it means that your direction of motion is still going forward, but you will be slowing down because your acceleration and your velocity is in different direction. Okay, refer to your kinematic notes and you will see that if A and V are of different sign, it is slowing down. If A and V are in the same direction, it will be speeding up. So the answer to this question is the direction of motion remains the same, right? If you are still having difficulty understanding this, ask yourself. Initially, the server is moving forward, right? In order for it to go backwards, it must undergo U-turn. Has the server reached a point whereby V is 0? Because V is 0 is an indication of U-turn, right? So since the V is not 0 yet, the server will be still moving forward. Right? So that answered the first part. Second part is what happened to the velocity? So since V and A are of different sign, your velocity will decrease. Okay, if you are still unable to understand this, that means there are still some more fundamental knowledge that you are not getting. So please approach your teacher and ask him why.